Hello, you welcome back to our channel. Thank you for joining me, Ada, on this platform again. Now, today we'll talk about elastic properties of solids. Elastic properties of solids. Quickly, what is elasticity? Elasticity is the ability of an elastic material to retain its elastic property or retain its elastic properties when stretched by a force, provided the elastic limit is not reached. Now, there are some things you should be familiar with when we are dealing with elasticity. One, the force applied to that body is known as F. Let's assume we have a spring. Okay, you have a spring. You have a spring. Is a spring is of a particular length. So there will be also an extension. An extension is always equal to the final length, which I can call L1, minus the initial length, which I can call L0. So that is what the three things that are important. And you should also know that the force applied to an elastic property is directly proportional to the extension produced in that elastic property. What does that mean? You can write that mathematically by saying F is equal to a constant times the elastic property, extension of that elastic material. Now, let's go straight to the question we have on ground. We have question 1. An object weighing 0.6 Newton is hung on a spiral spring and causes it to extend by 0.6 centimeter. The object is removed and a block of wood replacing it causes the spring to extend by 10 centimeter. What is the weight of the block of wood? Two things are involved here, the force and extension. So I can easily say I have F1, which is equal to what? 0.6 newtons. I can say I have my first extension. When the force of this amount is applied on the body, you have an extension of this, which is 0.6. You have 0.6. So if you have it that way, how do we go? The next one, he said there's if it's been extended by 10 centimeter, what's the weight on that body? What's the force applied on the body? So F2 is unknown, while extension 2 is 10 centimeters. So how do you think we can go about this question? It's just a simple proportion question, a direct proportion question. So all we do, we can solve proportion question by cross multiplication approach. So let's go that way. Let's go that way. Let's go that way. So I have 0.6 producing 0.6 newtons producing 0.6 centimeters. 0.6 newtons, it produces 0.6 centimeters. Unknown. So I can say Z newtons will produce 10 centimeters. By the time I choose to cross multiply, what do we have? We have Z times 0.6. Dot means times is equal to 0.6 times 10, isn't it? And that means our Z can be equal to, or you can still retain your 0.6. So dot is 0.6 is equal to 0.6. 0.6 times 10, that is 6. Divide both sides by 0.6. So Z can be equal to, what is 6 divided by 0.6? You have 10. So we have If 0.6 Newton can produce 0.6 centimeter length, then 10 newtons will also produce 10 centimeter length. Can you see that? Just a direct proportion. Let's solve example 2. Example 2 says that you have use the following data to determine the length L of a wire when a force of 40 newtons is applied, assuming Hooke's law is obeyed. Hooke's law, what does Hooke's law state? F, the force applied to a body, is directly proportional to the extension experienced by that body. That's just what Hooke's law states. And that's why F is equal to constant times the extension. So here, you have 0 newtons producing, or when 0 newtons is on 600 millimeter, when we have 15 newtons, there will be a new length of 600.5 millimeters. When we have a force of 20 newtons, we have an extension, or we have a length of 600.1 millimeters. So when we have a force of 40 newtons, what will be the new length is unknown. So I think wisdom requires that you compare the forces and the lengths together. So I can say my F2 minus my F1. That will give me what? Something. Then my E2 minus my E1. That will also give me something. So that is 600.5 minus 600. And that should be equal to what? 0.5. The first one is 15 minus is 0. 15 minus 0, and that is 15. That means I can say I have a force, my force to be equal to 15 newtons, and my extension to be equal to 0.5. 0.5 millimeters. Now let's go. Let's quickly, I have already force is 15, the extension is 0.5. So I can get my constant. Now we use it to solve for other lengths. It's as simple as that. So I have 15 to be equal to K times 0.5. So K can be equal to 15 divided by 0.5. What is 15 divided by 0.5? You have 30. So my constant is equal to 30. Now, having gotten this constant, I can go and solve for this length by comparing 40 newtons and 20 newtons, then the length minus 601. So here we go. Here we go. I can now say that my force, which is 40 minus 20, can be equal to K, constant open bracket, what? L minus 601. What is 40? Sorry, 601. This is 20, can be equal to 30, open bracket, L minus 601. And how do you go with that? All you have to do is what? You write your 20 can be equal to what? 30L minus, what is 30 times 601? 601 times 30. Don't forget to expand this bracket. 30 will open up the bracket. So we have 18,030. So what do we have now? This, you have 20 plus 18,030 to be equal to 30L. Isn't it? So this plus 20. So you have 18,050 is equal to 30L. Let me round it up here. Divide both sides by 30, you have 18,000. Okay, let me just divide here by 30 by 30. 30 crosses 30. So my L will be equal to what? 18,050 divided by 30. That will give you 601.66. Then put your units millimeters. That gives us our answer. So you can compare, look at the pattern. 600, 600.5, then 601 will now be 601.66 millimeter, or you have 7 millimeters. 601.7 millimeters. You're having the same value. Thank you for staying with me on this session. I will appreciate if you keep subscribing and sharing my videos. Thank you very much. If you want to reach me on this contact 081 64 86 9470. Thank you for your time. I see you later.